All right, let's put everything together here in terms of using first and second derivatives to be able to obtain a sketch of a curve. In this example, we're going to use, I think we'll just use a polynomial function because that's generally a good one to use the derivatives are nice and easy and it can help us to illustrate sort of the concepts a little bit easier. So let's say I have my function is going to be x to the fourth minus 12x cubed plus 48x squared minus 64x. And so what I'm going to want to do right off the bat is I'm going to want to take the first derivative and the second derivative of this function. So let's go ahead and do that. So I've got 4x cubed minus 36x squared plus 2 times 48, that is 96x minus 64 for my first derivative. And then the second derivative, I'm going to have 3 times 4, so that's 12x squared minus 2 times 36 is 72x plus 96, and then the derivative of 64 is just 0. Okay, so now I've got my my function, the first derivative and the second derivative, and with these in particular, it's going to be really helpful to factor these out if we can, because that's going to show us really where these graphs equal 0, and that's the points that we're most interested in. So remember, you can go back and pull out your algebra book if you want. There's lots of neat tricks that you can do for factoring. The one thing I like to use is technology, just because it can be really helpful. So, like for example, if you want to use Wolfram Alpha, you just say factor x to the fourth minus 12x cubed plus 48x squared minus 64x, and hopefully I typed that in right, and there we go. There we have it. So this equals x times x minus 4 cubed. So you can do that for the second and third, or I mean for the first and second derivatives also if you want. So if you factor those ones out, you're going to get 4 times x minus 1 times x minus 4 squared. And if you factor this out, you're going to get 12 times x minus 4 times x minus 2. All right, and I went ahead and did those before just to kind of save us some time. But just remember, a lot of these you will have to factor, or you can attempt to factor to hopefully make your life a little bit easier when you're looking for where these are going to cross 0. All right, so here we're going to look for points of interest. And I'm going to draw a little number line here to help us get organized. There we go. All right, so looking at these two equations, we want to find out when both of them are equal to 0. Well, okay, so that is 1, 2, and 4. So those are my points of interest, because the first derivative equals 0 at 1 and 4, and the second derivative equals 0 at 4 and 2. So we come down here, here is point 1, point 2, and then this is not to scale, but there's point 4. Then over here I'm going to put the first derivative and the second derivative because it's going to sort of just help us to figure out what's going on here. Okay, so with these you can there's a couple of different ways that you can do these. You can plug in numbers, like for example just take 0. If you want to figure out if the first or second derivative, what it's doing on this side of 1, you can plug in 0 here, maybe 1.5 here, and 3 here, and 5 here. So you can do all those calculations, and then that'll tell you if it's positive or negative. Or another thing, if you have access to a graphing program, you can, let me find ours, there we go. All right, we can just graph them. So here we have, I'll do the factored one, 4 times x minus 1 times x minus 4 squared. So that's our first derivative. Our second derivative is 12 x minus 4 and x minus 2. All right, so let's take a look at these real fast. Pull them in there. All right, so this purpley looking one, is our, actually let's take our second derivative out of there first. Okay, so looking at this is our first derivative. So I see that before 1, it's going to be negative because it's down here. After 1, it's going to be positive. Or I guess between 1 and 2, so 1 and 2, it's positive. Between 2 and 4, it's positive. And then after 4, it's positive also. Okay, so then here's my second derivative. Looks like second one's going to be positive from negative infinity to 1. So there's 1, so it's positive, positive. Then negative between the two, between 2 and 4. And then positive after 4. All right, so let's go back to here. All right, so here I wrote that information down. Again, you can do this analytically if you want, but for me, I just sure love technology because it makes our life a lot easier. So let's sort of get a picture of what this graph might look like. So over here, this is going to be decreasing. So remember, the first derivative tells you if it's increasing or decreasing. So this is going to be decreasing and concave up. All right, so let me continue to draw. This is sort of sketch paper anyway down, so this isn't, you're just kind of trying to get an idea of what this might look like. All right, so if it's decreasing, it's going down, but it's going to be concave up. So that means it's going to sort of come in like this maybe. So now let's go to this one. This one is going to be increasing and concave up. So it's going to continue to go like that. So let's kind of bring it up like this maybe. Yeah, not to scale again. That's kind of a weird looking deal. Okay, so here we have it where it's still increasing, but it's going to get concave down. So instead of like this, that means it's going to come up, but it's going to be decreasing. So it'll it'll be increasing, but it'll be concave down. Sorry, so it's going to come kind of like this, maybe. Like that. And then, here we go. This is kind of a surprise. Then it's going to hit 4, and then it's going to be increasing and concave up. So actually, it's not going to, go down. It's just going to shoot right back up like that. Normally, I'd give ourselves a little bit more space so it doesn't run into this, but that'll kind of get us an idea of what this might look like. So here we have it, the concave up, right? Then the concave down, but it's still increasing, and concave up again. So concave down, remember, goes sort of brings it like this, and then whoop. All right, well, let's take a look at how we did. So here we go. Let's find our handy dandy graphing program, and let's plug in x. Whoops. Where did that go? There we go. X times x minus 4 cubed. Aha. Let's get rid of that. Well, not too shabby. I mean, my graph definitely has a lot to be desired. Let me go back and forth. Really not as good as the real deal. But you see the shape there, it kind of hits in there to 1, goes back up. You have a inflection point here, but then it pops back up instead of going under. So this is a point right here where you'd have a derivative of 0, but you wouldn't necessarily have a local min or a local max. So that's the kind of instance where that happens. But as you can see, we estimated it, not too bad, just using the function itself and the first and the second derivative. So that's how you go about those. Um, that they take a little bit to get used to. A lot of it, a lot of the hard part in these problems can be just the factoring and simplifying things. So remember, make sure you have a good grasp on how to do it, but also you can use some technology like Wolfram Alpha or something like that if you want to either double check yourself or make your life a little bit simpler.